So we're going to continue our discussion from last time. This is worksheet number 8, page 2. Okay, we talked about how permutations order matters, and we talked about combinations, it doesn't matter. Okay? And then we also talked about the formulas for those. So we have the formula for permutation. Okay, is how many total items do we have? That's n factorial. If you're gonna use all the items, then that's it. It's n factorial. But if you're not gonna use all of them, you have to leave some out. So the formula takes care of that part. Okay. And then the combination is the same thing, except for what? It has this extra piece that takes care of duplicates. Okay? Takes care of duplicates. All right. Okay, so let's take a look at number 9. So I'm going to do the odds. Okay, so so order matters. So we're taking 3 children and arranging them in 3 different ways. Or, 3 at a time. So we're using all the children to rearrange. Okay? So if I finish my diagram on the board here, so I have 2 with the oldest first. I also have 2 with the youngest first, if I switch those. And I have 2 with the middle first. Middle child. I'm a middle child. So okay. So there's 6. All right. So the formula is not necessary. We're using all of them, so we just do 3 factorial, which is 3 times 2 times 1, which we knew it was 6. 1, 2, 3, 4, 5, 6. Okay. All right, so that's the one we talked about last time. What about number 11? So we just discussed this one in class. So people on standby don't have their own seats. There's 5 seats that are remaining. They're just gonna, pick 5 people and sit them wherever. So order does not matter. So 9 passengers with only 5 seats. What are the different ways they can be selected? Okay. So if we were using all of them, we would just leave it like that. We're not. We're only using 5. So, I'm sorry. Yeah, we're only using 5. So we got to get rid of the 4 that we don't need. And then I got duplicates right there. Okay, then we have, so this is 4 factorial. Now you can actually type this in your calculator. Okay? So in your calculator, you can do divided by 4 factorial times 5 factorial, but you have to put parentheses. If you don't put parentheses, it's going to do PEMDAS and it's going to be incorrect. Okay? It's only going to divide the 4 and not the 5. Okay? But now guys, this 4 is going to cancel out the first, starting with the right, the first 4 numbers, or the last 4 numbers of the 9. So that's going to leave us with the 5. So 1, 2, 3, 4, 5. Okay, the 4 through 1 is canceled out because of that 4, but I am still left with the 5. Okay, I'm running out of room, so you can do the whole thing all laid out if you want, but this saves us a little bit of time here. Now you can start canceling stuff out, or you can just do 9 times 8 times 7 times 6 times 5. 15,120. Divide that by 5 times 4 times 3 times 2. Okay. Issues, questions with number 11? Yeah. If you're gonna, yeah, you can cancel out the 5. You can cancel out. You can do 6 divided by 2 is 3. You can do 8 divided by 4 is 2. You can do 9 divided by 3. I mean, it gets kind of messy. If you're gonna do it that way, I would just use your calculator. And the book is going to show you all those cancellations, which is fine. But if you have a calculator, then just you can actually just use that. Yeah. Okay, number 13. So number 13, we talked about this one already. Order does matter in a race, so that's permutation. So 6 horses, 6 horses, and we're using all 6 horses. We're not going to just say, who was first, second, and third. It's just all 6. So that's the second 6 there. And if you're going to use up all the numbers, then you don't need to divide by anything to get rid of any part of this 6 factorial. So it's just going to stay 6 factorial. Which missing that. Okay. Number 15, does it matter how a baseball manager orders his batting lineup? Who's going to bat first, second, third, fourth, fifth, so on and so forth? Does it matter how he chooses it?
No.
Yeah. You don't want the last person batting first. Okay? So order does matter.
You said yes because what?
Because it's like who's batting first? It's not anybody. It's the first batter.
My brain is so
Yeah.
nonchalant. I just think that nothing matters. That's how my brain thinks. It's so nonchalant. So
All right.
when I read this stuff, I'm just like, huh? Okay.
This is number 15. Okay. So yeah, there's got to be an order to things to play the game. Okay, the players just can't just say, "Hey, you know what? I feel like batting right now." Is it your turn? No, sorry, sit down. You know what I'm saying? Like, it's not just people just do whatever they want. They have to follow the order. Okay, I gotta wait till you guys bat, then I can bat. It's a particular order. I mean, you got to know baseball for that. Because if you look at number 16, that same manager wants to select 3 of the 9 players to sing the national anthem. Who cares who he picks? There's no particular order. All right? That's like a random, okay, you. It doesn't matter. And when you're standing up there singing the anthem, it doesn't matter how you stand either. So that one, order doesn't matter. You're just singing a song. Well, that's different. Yeah. Yeah, I mean, assuming they're all musically talented, then it's just whatever 3, I don't know. Order doesn't matter for selecting those 3 to sing. But to play a game, yes, there's a particular order. Okay. All right, so let's do one more odd. Okay, swim meet has 12 participants for the 50-meter swim. The 3 fastest speeds receive medals. Yes, definitely matters. Because who's going to get the gold, who's going to get the silver, who's going to get the bronze? That definitely matters. Okay? So order matters for number 17. So that's permutation, 12 participants, 3 different ways. Again, you don't have to do the whole formula. You just have to use the first 3 numbers of 12. 12, 11, and 10. Okay, so guys, now it's your turn to work together in your partnerships and turn in one paper. You're going to do some evens that I'm about to... so I want you to turn in with the work shown, okay, with the work shown. Ten, 14, and 18, okay? So worksheet number 9 will also go through this type of questioning. But for your homework for 11.7, you have the basic concept of permutation, but there's a couple more specifics we have to go through, okay? So let's go ahead and turn to worksheet number 10. Worksheet number 10. We're going to talk specifically about some extra requirements for different things here, like a code. All right, so go ahead and get there. Let me erase this. All right. Okay, so remember our discussion about the 4-digit ATM code. All right. If there's no restrictions, just okay, 10 digits, 10 times 10 times 10 times 10. If you put a restriction about no repetitions, then it's 10 times 9 times 8 times 7. But this is even more restrictions than normal. Okay? You have a password to gain access to a computer account. So it consists of 2 lowercase letters. I mean, that's a restriction. It can't be letters or numbers. It has to be letters specifically. And then followed by 4 digits. So our situation this time has 6. Okay, we have 6. 1, 2, 3, 4, 5, 6. Okay, this is a better password than a 4-digit ATM card, okay? Or code. So, the first 2 have to be letters. So you have the A through Z to choose from. And A through Z again, because we can have repetition. It's permitted. So how many do we have in the first option? How many letters? And then again, 26. Okay. We're allowed to repeat so we can have AA, for example. Then, for the digits, same thing as last time, right? 0 through 9 every time. That's 10 each. So you're going to have to multiply all those numbers. Let me save you the time. And it's 6,760,000 possible options here. Okay? One option could be AA 1111. That's 1. And we have to do, if you go through that, we could have AA 1111-2. And you can go through all those different possibilities. You'll be there a very, very long time trying to come up with 6 million, almost 7 million codes, okay? All right, guys, what if you cannot repeat any of the letters or numbers that you use? Yeah, we got to subtract. So let's put them back out here. So remember, this is the letters. So the first option, I still have 26 options, but the second option is, guys, so 26 total here, and then 1 less because you cannot repeat the letter, and then 10 in the first one, 9, 8, 7, just like before. Multiply all these, let me save you the time. It is 3,276,000. So again, you put restrictions, look at the options. It's got cut in half. This is good news for, not for you, but for the hacker or the thief. All right? Restrictions cuts your options in half. All right, let's take a look at the third scenario. So this time, there's more restrictions. 1, 2, 3, 4, 5, 6. All right, so the first restriction is that the first one has to be a vowel. So there's A-E-I-O-U, that's 5. 5 options there. What about the second letter? How many? If it's, you cannot repeat. So I only have 4. Oh, sorry. No, this is the whole alphabet this time. So 26 minus 1 would be 25. Yeah. So the vowel restriction was the first spot. The second spot, you could use any of them, but you can't use the one you just chose, so one less there. Then we have the digits, and it says the first digit cannot be a 0. Okay, so remember you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so all it's saying is, okay, you're not allowed to use 0 for the first one. Okay, so how many do I have? So this is 10 total in each case, but I can't use the 0, so I only have 9. Right? Now, that's only for the first digit. The second digit, I can put whatever I want, except I can't. So let's say we chose 1. Now I can't use 1. I can use the 0 for the second number, but I can't use 1 because I already chose it in the first one. So that leaves me with 9 again. Okay? So remember, 10 digits if there's no restrictions. If there's a restriction, you can't use 0, there's 9 digits then. The restriction for the second one, you could use 0, but you already used one of those over here. I just happened to choose 1, so I can cross it out. 9 again. All right, so now, let's say I choose 2. So I can use this one, and I can use this one, so I have 8. Okay. So now it's just going down by 1. So multiply all those, and that's going to give you 567,000. Wow, we went from 3.3 million to about 500,000. Okay. So what is this trying to tell us? The more restrictions you put, the less possibilities there are. It makes it easier for hackers. So let's put that in reverse. The more numbers you put with the least amount of restrictions, meaning I could put a letter, a number, or a symbol, it increases your options, making it harder for someone to figure out what your code is using some type of technology or whatever. Okay? So the longer you do it with more stuff, uppercase, lowercase, letters, numbers, symbols, mix it all together, and it's going to be very hard for them to get your password. Okay. Any issues, questions for number 1? Okay. Let's talk about number 2. So we're at Best Buy, and there's a manager named Sadie Bragg. She wants to display the new iPads, Apple iPads. They are different colors: tangerine, strawberry, blueberry, grape, and lime. Of course, this is fictional, but the floor manager decides to display one of each color iPad on the shelf. Okay, how many different ways can she display the iPads on the shelf? How many iPads are there? How many colors? 5. Okay, so there's 5 different color iPads. So basically it's 5 factorial. Okay. Why? Because remember, she has 5 spots. The first option, she has 5. Once she chooses that, she only has 4 options left. 3 options, 2 options, and then her last spot, she can only put whatever's left over, which is 1. 1 iPad can go there after you've chosen 4. So that's the same thing as just 5 factorial. Okay. Now, here's a restriction now. She wants to place the strawberry iPad in the middle. So how many options does she have for the middle? She's already made the option. She's made the choice. I want the strawberry in the middle. That's one color in the middle. Strawberry. Everything else, put whatever. Right? So if you were to put the strawberry in the middle, and we go from left to right, then how many does she have to choose from for the first spot? 4. Then 3. I got to skip the middle. I already put an iPad there. So 2. And then whatever's left over goes there. So you have one option. So notice how the 1 appears twice. Okay. 12 times 2 is 24. Look how dramatically her options went down once she made a decision about where one was going to go. Went from 120 to 24. Okay, now she wants the blueberry on the first spot and the strawberry in the last spot for whatever reason. Okay. So guess how many options she has for each one? Well, blueberry, that first spot is only 1, and the strawberry is only 1. There's only 1 blueberry and there's only 1 strawberry. All right, so she has 5 total iPads. She just used up 2. That leaves us with, wait, why do I have 6 in here? Sorry. So, she has 3 left for that spot, 2 left for that spot, and 1 for that one. Okay. Okay, so that is these are permutations, or I'm sorry, these are the counting principle with restrictions. Okay, these are factorial questions, and you're using up all of them. So technically, it could be a permutation, but it's just not necessary to use the big old formula, and it's confusing if you do. But number 4, it says consider 5 letters A, B, C, D, E. How many distinct ways can 3 letters be selected and arranged if repetition is not allowed? So the only restriction is just don't repeat it. So that sounds like a factorial. You know, numbers going down by 1. All right. So there's 5. Order matters. And you're only going to choose 3. So we're not using all 5, so it's not 5 factorial. It's just use the first 3 numbers of the 5 factorial. Great. 5, 4, and 3. Those are the first 3 numbers of 5 factorial. Okay? It's not necessary to do the whole formula. You can if you want. 20 times 3 is 60. Okay, number 5. Actually, we're running out of time, so let's talk about... Okay, let's talk about the words, the letters in the words. Okay, so we're going to talk about 7 and 8 in a minute. Before we do 7 and 8, I want to point out a few things with an illustration. So, the word car. How many different ways can I arrange the letters? These are 3 different or distinct letters. How many different ways can I arrange it? 6. How did you get that? That's correct. It's 3 factorial, right? So this is 3 factorial. Now, how can we visualize this 6? Okay, so car, C-A-R, that's one way. I can switch the A and the R, keep the C first, just to keep track. That's another way. Let me put the A first. A-C-R, let me switch the C and the R. A-R-C. Let me, oh, that's art. So let's put, what's next? The R first. And then the C-A, and then RCA, that's a brand, right? And then rack. So 2, 4, 6. Those are your 6. Now the reason why we have 6 is because these letters do not repeat. But let's say if I have the word Bob. Okay? It is not 6 anymore. Let me show you why. Actually, how much do you think it is? We'll see. Let's put this sample space out here. So if I keep the first B, intact, and I switch the O and the B, I get BBO. Okay, let me put the O first. Then I have OBB. Now let me switch those 2 B's. Looks the same to me, right? Okay. That's not changing anything because the letters are the same. Let's put the other B first. From the beginning, the second B, I'm going to put him first. That's the same thing as the first guy, right? Let me go ahead and switch the B and the O. Okay. Because we have a repeating letter, I only have Bob, I have BBO, and I have OBB. All right? This doesn't count. It's already used up right there. This doesn't count. He's right there. And BBO is right there. So, what does this tell us? We only have 3. So how do we get this 3? All right. So what we need to do is take the 3 factorial that we would have used if the letters were all different. We need to divide it by the duplicates. Okay? Which B is repeated twice. So since B is repeated twice, I put a 2 down here. There's my 3 that I need. So what I'm trying to say with this is, okay, if there's repeating letters, we have to put how many duplicates there are in the bottom. So it takes away the duplicates from your sample space, all right? So let's take a look at Mississippi. Anybody from Mississippi? Can everybody spell it without looking? I think there's like a song or something you're supposed to memorize. Or a tune or something. All right. Pretty hard word to spell. So It's because there's a lot of repeating letters. So, how many I's are there? 4. That's going to create duplicates, okay? So how many S's are there? 4. How many P's? 2. So I'm only looking for the duplicates. That's the problem, is the duplicates. So, how many letters total? There's 11 letters. So, if all the letters were different, then we would have 11 factorial by itself. But because there's duplicates, remember I just showed you with Bob, okay, we have to divide by the duplicates. So I have 4 I's, I have 4 S's, and I have 2 P's. Okay, so those comes from my I's, these are my S's, and those are my P's right there. Those duplicates, those letters will create duplicates, so all you have to do is put this in your calculator like this. With parentheses, and it will give you 34,650. Or you can just lay it all out and start canceling stuff out if you want. Okay. Okay. So that's all we have time. So let's go ahead and do number 8 in your turn in. Let's do Cincinnati. So turn in number 8 and number 10. Okay, 8 and 10. Along with your other questions, okay? And that's going to be all for today, all right?